Today we're going to talk about arrays and data files. To do this, we're going to back up a little bit first and just discuss what a data file is and how they're used. Data files can be plain old text files. You can get into Nano and just type in the data. It doesn't require anything special, and then save it. In this particular case, you see on the right-hand side, I've listed with the cat command a file called data.dat. The suffix for data file is not important. .dat is one that's commonly used, DAT for data. TXT for text, that's another common one. But all we've got in this data file are a bunch of numbers, and they were typed in with Nano as you'd expect. Now if you take a look on the left-hand side, you'll see the program that reads from this file. The main things to understand about this program are, first off, we have a new include file at the top. Underneath IOStream, we've also included the fstream header file. This is the file stream header file, and this will allow us to open up a connection to this data file and read the data. And you'll see how it's used in just a moment. As we go down to the declarations, you can see that apparently what we're going to do is read in the values and add up a sum. So we set the sum to 0. We also have a variable called inFile. Notice that inFile is of type ifstream. This is input file stream. This data type comes with the fstream header file at the top. That's why we included it. It allows us to create an input file stream variable. We should always look at files as if they were streams, as if things were flowing into the program and flowing out of the program. That's what happens with cin. With cin, when you type something to the keyboard, you have a file stream, an input file stream that streams it in, and the extraction operator pulls data out of the stream. Similarly with cout, you have an output file stream. We place things, we insert them in the stream, and they flow out to the display or to the printer or wherever we've routed that. So here you see we have an input file stream variable called inFile. The name of the variable is not important. You can call it anything you want, but inFile seems to make sense. And now in the input and processing section, you can see that we tell that variable to open up a connection to a data file. .open is a function that's built into the file stream. We got it for free automatically when we declared our file stream variable, so that's great. We'll use it. So we'll tell inFile to open up a connection to the outside world and to connect it to data.dat. And so now we have a pipeline that's coming from that data file into our program through our file stream variable inFile. The while loop uses that. The while loop extracts things from inFile. So it pulls the first thing out of the stream, and that's the number 12, and puts it into num, and then we add that to the sum. Then we come back around, we extract the next value, 34, and add that to the sum. Then we come around and we extract the next value, 25, and we add that to the sum. The while loop will continue until the extraction process fails. The nice thing about the extraction operator is that it returns a Boolean value, true if it worked and false if it didn't. If it can't extract any more data, if it's at the end of the file, it will return false, and the while loop condition will be over and we'll go to the next line in the program, which in our case simply closes the pipeline. We close the input file stream by using the close function that's built into file stream variables. And now we're good. We've read all the data, we've calculated the sum, and we can print it out. So that's a simple program that uses summation. Now we can modify this to make a few changes to it. One of the things we might want to do is count how many items we've read. So here I have a variable called n that's been declared that will be that counter, and consider what it would take to do that counting. What modifications would we have to make to this program? It turns out it's not much, right? We just add 1 to n every time we read a value and process it. And when we finish with the program, we can print out n and we'll have that. So there's an easy way to read data in and count how many values you've read. And that can be important, especially if you're going to put that data into an array, which we'll see later. Now let's see if what would have to do to calculate the mean. And that's trivial, because we're adding up the sum, and we are also counting how many items are there. The only tricky part is when you compute the mean, we'll have to make sure that we typecast either the numerator or the denominator, because sum and n are both integers. So for this to be real number division, we'll have to typecast one of them, which we do. We typecast sum as a double. Now, what if you wanted to count how many values in this data file were above the mean? Here we have a problem, because we read the data in from the data file into our variable num one value at a time, and after we were finished with one value, we replaced it with the next. So we don't actually have the data. We didn't store it in this program, and now you can see this is very similar to where we started with our discussion on arrays. We need a place to store the data. So in this version of the program, up at the top in the declarations, num has now been declared to be an array of 100 data values. So that means we can read up to 100 values from the file. We're going to count how many values are above the mean, so we have a new variable called above. And otherwise, it's pretty much as it was before. We go ahead and read data, only now when we read data, we put it into a location in the array. So when n is 0, we put it into location 0. The next time around, n has 1 added to itself, and we put the data in location 1. We increment n to 2, and the next item goes in location 2. And so the while loop walks us down the array, reading data into one element after the next all the way down. When it's finished, our array, which had 100 values in it, has got some data values in it. Now there might not be a lot of them. We counted 9 in this case. So that means we have a partially filled array. Of 100 possible elements in the array, only the first 9 have data in them. But that's okay, because we know how many have data. We counted them. And so our for loop at the bottom is able to go through the array, all the elements from element 0 to element 8. That's the 9 elements. It's able to go through all of the elements one by one and compare them to the mean, and if any of them are above the mean, add 1 to a counter, our counter for above. And then we can print that out along with all the other data that you see down below. This is the entire program, slightly larger version of it, but you can clearly see the importance of having an array, so that when we launch our while loop, we can read data into the array and count the values as they're read in. And once we have that count of how many values are in our partially filled array, we can run for loops from there on to just go from the top of the array, element 0, right down to the last element that was filled. We know how many there are, because n tells us that, and process that data. So arrays are the best answer to this type of problem, where you want to read data in, and then after you've got it in your program, run it through a bunch of processing operations. So that's it for files. Thanks for watching.